Hi everyone. Today we are solving a really interesting problem from leetcode called minimum number of flips to make the binary string alternating. We are given a binary string S and we are allowed to perform two types of operation on the string in any sequence. The first operation, type 1, is remove a character at the start of the string S and append it to the end of the string. The second operation, type 2, pick any character in S and flip its value from 0 to 1 and vice versa. We need to return the minimum number of type 2 operation that such that S became alternating. So again, we are given a binary string made of zeros and ones, and we are allowed to do two operations. First, we can rotate the string by moving the first character to the end, and second, we can flip any character, meaning we can change a 0 into a 1 and a 1 into a 0. Our goal is to find the minimum number of flips needed to make the string alternating. In other words, the final string must look like either 010101 and so on, or 101010 and so on. So let's break this problem step by step. Suppose, for example, we have a string that looks like this one, consists of the characters 111000. As you can see, it is not an alternating string. But remember, we can rotate the string before flipping the character. For example, this string can be flipped to 110001 by moving the first one to the end. Also, it can be flipped to 100011 and so on and so forth. Each rotation might require a different number of flips. So our task is to try all the rotation and find the configuration that needs the fewest flip to become or to make the string alternating. The most straightforward idea to solve this problem is to try every possible rotation, like trying this rotation, this rotation, this rotation, and so on and so forth, until we found the fewest flip. As you can see, there are n rotation for the string of length n. So for each rotation, we can compute how many characters we need to flip to match the pattern, either 010101 and so on, or how many flips are needed to match the pattern 101010 and so on. Then we take the minimum. But the problem is that checking each rotation takes O of n time. And since we have n rotations, the total complexity would become O of n to the power 2. That will work for a small input, but it's gonna be very slow for large strings. So we need a better idea. Here is the key observation that leads to the optimal solution. If we concatenate the string with itself, something interesting happens. For example, if we have s equal 111000, then s plus s, if we can concatenate s to itself, we will have this string twice. Now, for every possible rotation of the string, every possible rotation appears as a substring of length n inside this doubled string. So the first string can be a substring of this string. The next rotation can be also a substring of this doubled string, and so on and so forth until we reach the end of the string. That means instead of physically rotating the string, we can simply slide a window of size n across this large or doubled string. This converts the rotation problem into a sliding window problem. Now back to the original requirement, which is returning the minimum number of type 2 operations to perform such that S becomes alternating. So we need to understand what an alternating string looks like. As we have said, we have two possibilities, either 0, 1, 0, 1, 0, 1, and so on, or 1, 0, 1, 0, 1, 0, and so on. So any valid alternating string must match one of these patterns. So for every window of size n in our doubled string, we simply count how many characters mismatch with each pattern. And then we take the minimum. Let's look at an example. If we have the string, again, 111,000, we need to match this string against the two patterns, either 01010101. And as you can see in this pattern, we have first mismatch, the second character matched, the third character is mismatched, the fourth character is mismatched, the fifth character matched, and the last character mismatched. So we have 1, 2, 3, 4 mismatches. 4 mismatches when we have start 0. So when we match against the other pattern 1 0 1 0 1 0, then we have one mismatch, two mismatches, two mismatches when we start with 1. But remember, we don't only flip the character, we also have another operation which is rotating or appending the character to the end of the string. So instead of recalculating mismatches from scratch for every window, means that we took the first window and calculating the mismatches, then going to the second window, calculating the mismatches, going to the third window and calculating the mismatches, and at the end we compare all of these mismatches and we return the fewest one. So we will track the mismatches using two variables. Let's call them mismatch 0 and mismatch 1. Mismatch 0, this will count the mismatches against the pattern that start with 0. And mismatch 1 will track or count the mismatches against the pattern starting with 1. As our sliding window moves, two things happen. One character enter the sliding window and one character leave the sliding window. So if we start, this is our first window, and then if we move to the next one, the first character leave the window and another character enters our new window. Then we will update the mismatch counts accordingly. This allows us to update everything in constant time per step, and that reduces the entire algorithm complexity to O of n time. Now, let's move to the code. First, we get the length of the string. Next, we create a double string. Let's name it capital S. Not the best name, but just for the sake of this explanation. This allows us to simulate every rotation using a sliding window. Next, we initialize our mismatch counter. Let's name them integer mismatch 0 and mismatch 1 initialized to 0. And also we initialize a variable called result that will hold the final result at the end. After that, we will now iterate through the double string. And at each position, we determine what character we expect in each alternating pattern. The patterns that start with 0 and the pattern that start with 1. So let's define it as character expected 0 equal I mod 2 times 1 and define another variable expected 1 that is the opposite. To show the expected character for each pattern. And if the current character doesn't match the expected value, we increase the mismatch count. So if S capital of I doesn't equal expected one, that will increment the mismatch 1. And also, let's copy it. If S capital of I doesn't equal the expected 0, that will increment the mismatch 0. Once the window size becomes larger than n, that means that we have already processed the first string or the original string, and then we need to process each sliding window that adding one character from the right and removing one character from the left. So once the window size becomes larger than n, we remove the effect of the character that leaving the window. And so I'll add the condition if I is greater than or equal to n, then I'll create another two variables that mark the expected character uh, uh, to be removed at that time. So let's call it previous one, and that will equal I minus n modulus 2, 1, either 0, and the same, let's name it previous 2, and let's leave it 0 or 1. And again, I'll compare against the variable previous one and previous 2, but this time, instead of checking the index at I, we need to check the index at I minus n. And instead of, sorry, I have to flip this, or no problem, I'm gonna rename this match 0. Instead of incrementing, need to decrement, because this is the effect of removing the character from the window. And the same of I minus n not equal previous 2, and that will decrement the match 1 mismatch 1. So this if condition is responsible for removing the effect of the character that leaving the window. So once we reach the size of n, that means that we need to compute the result. So if I greater than or equal n minus 1, at that point we need to calculate our result like it will equal the minimum of the current result and the minimum between the two mismatches. And after the loop, we just need to return the result. So let's run to make sure it's an error-free. Seems it's not, because I misspelled the expected one and expected two as well. So let's run again. Aha. So it seems it's not giving the right answer here. Like that. Let's quick check the code. We have double string. Expect. I exchange it, the two expected variables. So let's run again. All the test cases passes. Let's submit it. And as you can see, in terms of complexity, these algorithms run in O of n time. So it's a linear algorithm. And in terms of space complexity, is constant because we are using just some extra variables. And this is optimized sliding window solution. Instead of checking every rotation individually, we transform the problem into a substring window problem and update the mismatch count dynamically. And of course, this reduces the complexity from O of n squared to down to O of n. If this explanation helped you understand the trick behind this problem, don't forget to like the video and subscribe to the channel for more coding explanation. And I see you in next problem. Bye.